Okay, so Chapter 9, Section 4, we're going to be learning about multiplying square roots. So I'd like to start off with just the property, or the product property of square roots, which states that if we have a and b and they're non-negative real numbers, then, now, this first part, and I'll highlight it in blue. This first part we've already seen before, okay? And what this is saying is if you have numbers that are being multiplied underneath that radical symbol, you can separate them by putting other radical symbols. Now, if you're asking yourself, well, where did we see that? Well, remember, back in section 2 and 3, we looked at a problem like the square root of 20, which is really 4 times 5, and then we can separate that to give us 2 times the square root of 5. Well, that's exactly what the blue part is saying in this definition. On the other side, highlighted in yellow, what we're saying here is that we can, if we wanted to, start right here in the upper right-hand corner of your screen. I'm going to erase the 2 square root of 5. We could start with the square root of 4 times the square root of 5 and then go backwards. Okay? So that's exactly what we're going to be doing here when we talk about multiplying square roots. The key, and I'm going to write it in red. The index of the radical must be the same. Okay? And remember, the index is this number right here. Okay, so if nothing's written, we assume it to be a 2. Otherwise, we put a number there. So let's go ahead and let's look at the 2 examples I have here, and they're pretty straightforward. The first one is just going to be the square root of 3 times the square root of 7, which means I can write it as one radical, and then multiply 3 times 7 underneath to give me the square root of 21. Now, with the second example, it's a little bit more complex, because if you notice, the square root of 2 and the square root of 6, neither of those simplify any further. They are what they are. However, I can rewrite it as the square root of 2 times 6, which we know is the square root of 12, and the square root of 12 can be broken down into the square root of 4 times the square root of 3, which is the square root of 4 times the square root of 3, for a final result of 2 square root of 3. So if you think about this, and what just happened in this problem is going to happen a lot, which is you're going to first multiply. Actually, I need to be more specific. First, you're going to rewrite. Okay? You write that a little cleaner. Then you're going to multiply. All right? And then you may have to simplify. Some of them simplify, some of them don't. The first example, we couldn't simplify. The second one, we could. Okay? So let's look at another example here. So let's do 4 times the square root of 3 multiplied by 2 times the square root of 12. Now, there are a lot of different ways that you can do this, okay? Personally, find one way that you kind of like and stick with it. So, remember the commutative property. If you forgot about it, the commutative property just says this. If you're multiplying, the order doesn't matter, okay? For example, 2 times 5 is the same exact thing as 5 times 2. Now, the reason why I'm bringing that up is because when I look at this problem here, I notice I have a 4 times the square root of 3 times 2 times the square root of 12. Well, in my head, the way I envision this is I'm going to take 4 times 2 and then multiply that by the square root of 3 times the square root of 12. So I can easily multiply these two numbers first. 4 times 2 is 8. Times, now 3 times 12 is 36. And from here, I know the square root of 36 is 6. So this just turns out to be nothing more than just 8 times 6, which is going to be 48. Let me show you another example here. So let's do this one. We're going to do 3 times the square root of 2 multiplied by 2 times the square root of 30. So once again, the way I envision this, I notice all 4 of these numbers are being multiplied. So I can do 3 times 2 times the square root of 2 times the square root of 30. 3 times 2 is 6. 2 times 30 is going to be 60. And then from here, I can go ahead and try to simplify anything that I can. So on the right-hand side, the square root of 60 is really the square root of 4 times 15. All right? So that's going to be 2 square root of 15. And now that square root of 15, if you think about it, that is just 3 times 5. And that doesn't break down at all. Remember, you're looking for perfect squares. 1, 4, 9, 16, 25, and so forth. So I can rewrite the square root of 60 as 6 times 2 square roots of 15, which is going to be 12 square root of 15. So what I noticed is when students are doing radicals and multiplying and everything, what really makes this difficult is just all the simplifying you have to do. So anytime you make a step, let's say from this step right here where I just put that star in the upper left-hand corner, down to your next move, you always need to ask yourself, can I simplify? All right, that's what you got to ask yourself. All right, and if you can no longer do that, then that's how you know you're done. And you just got to practice. The more you practice this, the easier it's going to get, and the easier it comes to simplify stuff. Okay. So now what I'm going to do is I'm going to up the difficulty here a little bit. We're going to look at this example here. The square root of 6x to the third multiplied by the square root of 3x. Okay? So once again from here, notice that I don't have any numbers out front, so I'm not multiplying, but what I can do is rewrite this as 6x to the third times 3x underneath one big radical. Now, 6 times 3 is 18. X to the third times x to the first is x to the fourth. Now from here, remember, remember, you got to ask yourself, can I simplify? So maybe a nice way to approach this is just to focus on one thing and one thing only. So if you notice underneath the radical, we have 18 and we have x to the fourth. So maybe let's just focus on the square root of 18. Let's do that one first. All right. Square root of 18 is really 9 times 2. So that's going to be 3 square root of 2. So what I'm going to do is directly underneath, I'm going to put a 3, leave a little space, and put a square root of 2. Now I'm going to focus on the square root of x to the fourth. Well, remember, the index is a 2, so we can ask ourselves, how many times does 2 go into 4? Little simple division problem. So that's going to be 2 with a remainder of 0. So this quotient tells me I have x to the second outside, and then the remainder tells me that I have 0 x's underneath the radical symbol. So from here, I can just circle my answer, and I know I'm done. Once again, the hardest part about this is asking yourself, am I completely simplified? Okay, let's do another one here. How about 2? Actually, let's do this one. The square root of 2y to the third times the square root of 50y to the second. Now, this problem, once again, you can go directly into writing one big radical, write 2y to the third times 50y to the second, and you can multiply everything out if you wanted to. which I'm going to do here. 2 times 50 is 100. Y to the third times y to the second is y to the fifth. Now, I ask myself, am I simplified? And the only way you're going to know the answer is to try it. Okay? So, to the left here, I'm just going to write the square root of 100. Well, I know the square root of 100 is 10. Square root of y to the fifth, remember, you got an index of a 2, so what we're really asking here is 2 goes in the 5 twice with a remainder of 1. So, I have a 10 outside my radical symbol. The numerator tells me I have 2 y's on the outside. And then my remainder tells me I have 1 y on the inside. Now, there's another way that we can approach this problem. I'm going to write it in red because maybe you were like, why doesn't he just do this? So watch this. I'm going to rewrite the problem here. Okay. And right from the start, I'm going to try to simplify what I can. Notice directly underneath, there's nothing I can do with this number 2. However, that y to the third is going to be y to the first times 2y underneath the radical symbol. Okay? Now, directly underneath, I'm going to do the square root of 50 y to the second. The easiest one is that y to the second. There's going to be a y that comes outside. But that 50, the square root of 50, and I'll write it on the far right side of your screen. Square root of 50 is really 25 times 2. And we know the square root of 25 is going to be 5. So this will be, give myself some space, 5y times the square root of 2. So if you notice, right from the start, what I decided to do is simplify each individual radical. Now, when I go to multiply, notice I have, and I'm going to highlight for us so you can see exactly what I'm talking about. I have a y to the first and a y to the first. Well, that's going to be 5y to the second. And then underneath the radical symbol, I have, and I'll highlight for you so you can see what I'm doing. I have 2y and a 2. So what I'm going to write is 2y times 2, which I know that's going to be the square root of 4y. And we also know, I'm just zooming out here because I want to be able to see the original answer. We also know that 4, I can simplify the square root of 4. Put the 2 out front, square root of 4 is 2, times 5y to the second times the square root of y. And if you notice, 2 times 5 equals 10y to the second times the square root of y, which is the same exact answer of what we have above. There is no, this is the way you do it every single time. It's whatever you're comfortable with. If you just want to multiply and then worry about simplifying, I'm fine with that. If you want to simplify first and then multiply, I am fine with that also. What you just have to be able to do is find a way that you're comfortable with. Okay? Let's do one more example here. How about 6 times the square root of 2x squared multiplied by 8 times the square root of 45 x to the fourth. All right, now what I'm going to do here, I'm going to simplify each one first. I find that to be, for me personally, I find that to be just a little bit easier because the numbers are small, and I like that. So I will just draw a line, write scratch work. 6 times the square root of 2x squared. Well, that's going to simplify down into 6x times the square root of 2. Okay? Now, for the next part, 8 times the square root of 45x to the fourth. Well, the first thing I'm going to do is I'm going to look at the variable x to the fourth, and I know 2 goes into 4 twice with no remainder. So 8x squared times the square root of 45. Now I'm just going to keep breaking this down. Square root of 45 is really 9 times 5. And I know the square root of 9 is 3 times 8x squared, square root of 5. And 3 times 8 is 24, x squared, square root of 5. So I'm going to take my 6x times the square root of 2 and my 24x squared times the square root of 5. And I'm going to write that directly underneath 6x times the square root of 2 multiplied by 24x squared times the square root of 5. Now I'm just going to multiply everything. So 6 times 24 is 144. X times x squared is x to the third. And then we have the square root of 2 times the square root of 5, which is going to be the square root of 2 times 5, which we know. Let me write that cleaner. We know this to be times the square root of 10. And that's going to be our final answer. So the next couple examples, we're just going to combine everything that we learned from the very start of the semester on up until now. Directions are always going to be the same. Always be simplify. It's just the problems get a little bit more involved. And what I mean by that is this. So let's look at this example right here. We have 3 times the quantity 5 minus the square root of 2. And all I'm going to do here is just distribute. That's it. So 3 times 5 is 15. 3 times negative square root of 2 is literally just negative 3 square root of 2. And that's going to be it. Remember, you could only multiply radicals when they have the same radical symbol. This 3 out front is a whole number, so I can't do this. Like, that would be very bad. Okay, you cannot do that. 3 is a whole number. Square root of 2 is an irrational number. Irrational numbers multiply other irrational numbers. That's it. So now let me show you an example where we can do that. So here I have the square root of 2 outside of the quantity of 4 minus the square root of 10. Now, once again, I'm going to distribute, because that's what I normally would do to remove the parentheses. So square root of 2 times 4. Remember, 4 is a whole number. So it's going to be 4 times the square root of 2. However, the square root of 2 times the square root of 10, I can write that underneath the radical together because they both have the same exact radical symbol. So that's going to give me 4 square root of 2 minus the square root of 20. And we can simplify the square root of 20. So off to the right-hand side, square root of 20 equals the square root of 4 times 5, which is 2 square roots of 5. So 4 square root of 2 minus 2 square root of 5. Okay? Let me do another one like that. All right? So here's another one, just like what we just did. Square root of 12 times a quantity, square root of 3 plus the square root of 24. Okay? Well, remember, directions are simplify, which means remove parentheses. So I'm going to go ahead and just distribute. So all the radicals are the same. Therefore, I can do square root of 12 times 3 plus the square root of 12 times 24. Now, from here, we can go ahead and just do some simple math. So 12 times 3 is going to be 36. So this will be the square root of 36 plus 12 times 24 is 288. Now, the square root of 36, that's simple. We can reduce that. That is going to be a 6. However, the square root of 28, or I'm sorry, square root of 288, definitely more intense. So, off to the right here, I'm just going to write 288. And I'm going to find its prime factorization. It's so important that we can be able to do that. So, 2 times 144. And from here, I'm just going to stop. Because I know, and I'm going to write it underneath here, I know that I can separate the square root of 144 times the square root of 2 because the square root of 144 is 12. So this is just going to be 6 plus 12 times the square root of 2. Okay? Now, I can make these problems a little bit more difficult. The way that I would do that is I would give you two quantities. So the first one is going to be 2 plus the square root of 3 times a quantity 4 minus the square root of 3. Okay? Well, from here, we're going to just maintain what we've been doing the whole time. We're going to distribute. So I underlined a 2. 2 times 4 is 8. 2 times negative square root of 3 is going to be a negative 2 square root of 3. Now I underline the square root of 3. Square root of 3 times 4 is going to be 4 square root of 3. So I'm going to write that directly underneath. Put a plus sign in the front because it is positive. And then the square root of 3 times the square root of 3. Well, I'm going to write that over here to the right. We have square root of 3 times negative square root of 3. So the first thing I notice, a positive times a negative is going to be a negative. Square root of 3 times the square root of 3 is really the square root of 9, which we know to be 3. So, minus 3. Okay? Now, from here, we're just going to combine like terms. So, and I'm just going to come straight down for now. 8 plus 2 square root of 3 minus 3. And notice that 8 minus 3 is 5 plus 2 square root of 3. So that's the only way I can make this more difficult is just by giving you actual binomials to multiply. Okay? So let me go ahead and let me do some more of these examples here for us. So we'll do 3 minus 2 square root of 7 times 4 minus 2 square roots of 7. I'm just going to draw a little line, put scratch work over here in case I need it. So I like to underline and then draw little arrows so I know I'm distributing. 3 times 4 is going to be 12. 3 times negative 2 is negative 6 square root of 7. Now I'm going to erase my lines. Underline the negative 2 square root of 7. Draw some new arrows. So negative 2 times positive 4 is going to be negative 8 square root of 7. And then here's the last part. And this one is the tricky one. So just be careful. Negative 2 times negative 2 is going to be positive 4. Square root of 7 times the square root of 7 is the square root of 49, which turns out to be 7. Now you got to remember, this is 2 times that. So this is going to be 4 times 7. That's the tricky part, just keeping everything ordered, nice and neat, working slowly. So now we're going to combine everything straight down. We get a 12. We get a negative 14, square root of 7. And 4 times 7 is going to be positive 28. And then finally, we can add 12 plus 28 to give us 40 minus 14 times the square root of 7. Okay? Let's do, we'll do a couple more here. How about the square root of 6 minus 3 square roots of 8 multiplied by 2 square root of 6 plus the square root of 8. Okay. Remember, I'm going to just go ahead and write my little scratch work over here to the right-hand side. underline, arrows. Square root of 6 times 2 square roots of 6. So I'm just going to write that. Square root of 6 times 2 square root of 6, which is going to be 2 times the square root of 36, which is 2 times 6, which equals 12. Okay? Next, we're going to do the square root of 6 times the square root of 8, which is going to be the square root of 48. Now we can simplify that. The square root of 48 is really the square root of 16 times 3, which is 4 square roots of 3, and it's positive. So plus 4 square root of 3. The hardest part is just keeping everything nice and neat and simplifying. All right. Now I'm going to underline a negative 3 square root of 8 and distribute that as well. So negative 3 square root of 8 times 2 square root of 6 is going to equal, well, negative 3 times 2 is negative 6. Square root of 8 times the square root of 6 is the square root of 48, which we just learned is going to be negative 6 times 4 square roots of 3, and negative 6 times 4 is going to be negative 24 square root of 3. So I write that directly underneath. Finally, negative 3 square root of 8 times the square root of 8 is really negative 3 times the square root of 64. 8 times 8 is 64. And we know the square root of 64 is really negative 3 times square root of 64, which is going to be 8. So that's going to be negative 24. And I write that over here to the right-hand side. Now I just combine everything. I get a 12 minus 20 square root of 3 minus 24. And then 12 minus 24 is negative 12 minus 20 square root of 3. Okay? Now, the last couple examples I'm going to do here are the really special ones. So I'm going to put a big star. And these are very special because we get a big happy face when we see them because they're very simple. So I want to look at 4 minus the square root of 2 times the quantity 4 plus the square root of 2. So if you notice here, I got a 4 and a 4. I got a square root of 2 and I got a square root of 2. The only difference between these two binomials are the plus and the minus signs. And hopefully we recognize by now that these are conjugates. They're conjugate pairs, okay? And remember, so I'm just going to put recall right here. I'm going to do a really simple problem. X plus 2 times x minus 2. If we were to go ahead and distribute this, remember, you would get x squared minus 2x plus 2x minus 4, which is x squared minus 4. In other words, those middle terms, they always reduce when you have conjugate pairs. They always just cancel themselves out when you have conjugate pairs. Now, if you notice what we have here over here on the left-hand side, I'm just going to rewrite the problem here for us. As soon as I recognize I have conjugate pairs, I don't have to do all the multiplying. All I have to do is multiply 4 times 4, which is 16, and then multiply a negative times a positive, which is a negative, square root of 2 times the square root of 2, which is the square root of 4, which is 2. So it's just 16 minus 2. And 16 minus 2 is 14. And that's why we get really excited when we see these conjugates, because we can just multiply the first terms and the last terms and call it a day. So let me do a couple examples with conjugates, and then we'll be done with this video. So notice here, quantity of 2 minus the square root of 3 times the quantity of 2 plus the square root of 3, conjugate pairs. 2 times 2 is 4. Minus square root of 3 times the square root of 3 is 3. So 4 minus 3 is 1. I guess I could make this a little bit more difficult. But as long as you can recognize that we have what we call conjugate pairs, life is good. So notice here we have conjugate pairs. So 5 times 5 is going to be 25. A positive times a negative is a negative. And then 2 square root of 3 times a 2 square root of 3 is 4 times 3. 4 times 3 is 12. And 25 minus 12 is 13. So that's going to be it for this video here. The hard part is all the simplifying that we're going to be doing within these problems. So please just be careful when you do these problems. Make sure you simplify, and I'm going to write that word down because that is very important. All right, in the next video, we're going to talk about dividing rationals and radicals, and it's actually not that difficult. So, see you in the next video.